Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students. I am Raghunandan Sengupta from the IME department, IIT Kanpur, India. So, all of you are taking this project management course, and welcome back again to this 29th lecture. So, the total number of lectures, as you all know, is of 40 number of duration, which is of 20 hours. So, considering the concept which we have been discussing the last day, it was basically the concept of the PERT, and also we discussed about in details about critical path method, and if critical path is given, what is the overall average time. Average means expected time which is taken for any activity, and then considering the optimistic time, the pessimistic time, the most likely time, we found out how you can find E of t, that is the expected value, average time. We also found out that how the variance can be calculated for each and every activity job, and how given the concept of the variance, addition of the variance being possible due to the fact that the activities we consider in a very simplistic notion, they are independent, we can add up the variances and then find out the total variance of the path or the critical path or any subcritical path also. Subcritical in the sense those activities are not critical, and then we can use the concept of central limit theorem, find out what percentage of job should be finished, considering that your average time is, say for example, t, average number, and your deadline is d. How you can find out what is the probability of the work which is totally finished, what is the probability of the work would be finished between two deadlines, how the concept of cost can be brought into the picture. If you remember, I did mention quite a few number of times that in the PERT, CPM, and generally the activity on arc, activity of node concept, wherever you have, you are trying to basically find out the average time and what is the critical path based on which you will complete the job. So, the concept of trying to bring the resources, even though I had mentioned that in some details, but it was not considered in depth, and we will consider that as we go along in the 29th, 30th, 31st, 32nd class, and also consider that how the leveling of the resources can be done. So, come back to this slide number 356, it shows the contract is to be done and given, based on which you have the design aspect. So, A activity leads to B. So, it is very simply an activity of node, even though the nodes are not circular in nature, but it gives you a feel that how the overall project is being implemented. Then you give some marketing work is to be done, and as the design work is being done, marketing concept needs to be implemented in order to sell that product. So, that selling of the product can be either a moped, can be either a fridge, whether you are trying to come up with a new drug, it can be that, whether it is basically a social project, whatever it is, there has to be some marketing of that. Then based on the design and the marketing survey, you feedback which you get from the customers, you do a survey, the actual product which is to be sold, you do the test marketing, see what is the set of customers feedback, which is whether the price is too high, whether re-engineering has to be done, whether the features based on which you are trying to do the design for the product is absolutely in line or in tandem with what the customer wants. Then as you get the survey, obviously there are loops, but we are not going to consider the loops as I mentioned for the PERT, CPM, and the decision networks, at least for the bulk portion of the project management course. Then the development process, the development phase would come, then after the survey you have the analysis part, Then the marketing also does a detailed survey, what is the demographic concept for whom you are going to sell the product, whether it is for the teenagers, whether it is for the middle aged people, whether it is basically for people who are in the high income bracket or the low income bracket. Based on that, you combine the phase or the activity E, F, G as given in this slide, and then you do the presentation and finish off the project. So, this is a very simplistic project which I am just going to discuss with the students. Now, consider the same activity network diagram, which is again placed in front of you, which is slide number 357. But now, if you see the numbers which are there, so say for example, I am considering the numbers in such a way that the leftmost values which is there for A or B or say for example, C which is there, generally it means the earliest start and the latest start time, based on which you can find out what is the overall free slack and the total slack. If you remember, I did go into detail that what was the formula for the total slack, what was the formula for the free slack. That free slack has to be less than equal to total slack. If slack total or free slack is totally 0, then what does it mean? It generally means, as you can rightly point out, because considering that you have completed about 28 lectures of this course and you have been doing a lot of reading, trying to solve the problems. So, it means basically the slacks being 0 would imply that the activity of job are on the critical path. So, if you consider A, the earliest starting and the latest starting are given, the total number of days required to finish that work is given here. So, now I will highlight it for each and every activity. So, this is 5 for A, it is again 5 for B, it is 6 for C, it is 13 for D, 6 for E, then 6 for F, 6 for G. G, A, B, C, D are the activities, and lastly it is 6 for H. So, if I am able to calculate or go into the details, it means that earliest start you are going to start at t is equal to 0, and if you add the number of days, it is 0 plus 5. So, hence the earliest finish and the late finish for this job activity is 5 here. So, it is basically 5 here and 5 here. So, again I am highlighting this 5 and 5 here. Now, if I go into job B, so the total number of days required is 5. So, adding 6 plus 5 is 11 and adding 5 plus 5 is 10, which means that if you consider the early start, early finish, late start and late finish, considering the concept of the forward pass, that means you are going from the left to the right from where you start, which is the source, to the sink, and the backward pass where you start from the sink to the source, there it will give you the total slack of the free slack. So, the slacks which are given for this job would be, for B at least it is 1, then for C it is 0, I am just highlighting those. For D it is 0, then E it is basically given as 28 minus 12 or 22 minus 10, it is basically 28 minus 16, my apologies. So, it is basically 12, then for 8 it is G it is 8, for F it is 0 and for H it is 0. So, if I want to concentrate and find out the critical path, it becomes very obvious to all of us, considering that we have already done these concepts and the concept of free slack, the total slack is clear to us. It will be basically we will take the path which is A to C. So, I am just marking it with the hashed, it is A to C, then it will go to D, because I will not be taking a C to G, because that is not critical along the critical path. Then I will basically go to D to F, and then I will complete the overall project from going from F to H. So, these jobs which I am going to highlight now or circle now are not along the critical path. So, B is not there, E is not there and G is not there. Now, having said that, the data which is given in front of you gives the early start and early finish. So, we assume that the optimal, the pessimist time, the optimist time and the most expected time are already provided, based on which you can find out the average time. So, the average time which we find out for all the jobs are what I had already mentioned. So, basically for job A it is 5. So, obviously there would be variance. So, I am not going to discuss the variance, but come into the concepts as such. 5 is the expected time of the average time for B. Similarly, for C it is 6, for D it is 13, for E it is 6, for F it is 6, for G it is 6, and for lastly for H it is 6. So, you can find out the value of ET for each job, and I can find out the variance of each job. So, it is basically E T suffix I for the job number. So, I would basically be the job number, and adding up, if you know, and if you have gone through in depth the slides which I have discussed, my lectures which I have been repeating time and again, that addition of all the times taken along the critical activities gives you the time for the critical path, and addition of the variances along the critical activities or the critical path will give you the variance of the total critical path, and then we can find out the standard deviation. So, again coming back to the same diagram, the critical activities for the project is, as rightly pointed out in the last slide, which was the 357th, is basically A, C, D, F, H. For the overall project, even though the data is not given, but we considering the data is there and we do the calculations, the calculation concept remains the same, there is no change, but I am just skipping that part and going into the discussion directly. So, I add up all the variances, which is 1.78 plus 1. So, this is for A, C, D, F, H in that sequence. Then you have 4, then you have 0.69 and 0.725. So, to total variance is 7.72. If I want to find out the standard deviation, it will be very simply the square root of 7.72, which is the standard deviation for the path which is critical, which is A, C, D, F, H. Thus, the standard deviation as given in the third bullet point is found out to be 2.78 approximately. So, this information is useful for assessing the probability of the on time project completion, because PERT estimates make two assumptions, which again I am repeating. Total project completion time follows a normal probability distribution considering the central limit theorem is true, even though the distribution for each and every activity is totally different, which we have discussed. And the activity times are stochastically independent, because if they are not even independent, then adding up the variances would not be possible. So, as a result, please excuse me even though I am repeating that, but I strongly feel that the concepts lately which I am repeating time and again are very important to understand the general methodology of the concept based on which you will try to solve any problem in PERT, CPM and GERT later on. So, as a result, the normal bell curve can be used to represent the project completion time. So, normal distribution here implies that there is 50% likelihood that the project completion will be less than 30 weeks. So, if you add up all the times along the critical path, you will get the sum of the average time of all the paths which are critical. So, what I do is that if you see the calculation, I add up the expected value. So, this I is all those set of jobs or activities which are critical. So, here there is a 50% chance of completing that job before 30 weeks or whatever the value which I found out, and 50% of chance is there that the job would not be completed, 50% would not be completed within that actual time. So, this is not the due date is basically decided between the person who is doing or the group which is doing the project and the set of customers who will be served after the project is completed. So, and then again if I want to find out the delays, the overrun run cost, again I am just repeating for the sake of repetitions as things really get in a very fine tune for all the students. I need to use the probability concept using normal distribution or the normal deviate. So, what I do is that I need to find out the probability. So, this x is the random variable which denotes the time. So, if I want to find out what is the probability that x would be less than some d, d is the due date which I want to find out or which is given. So, it can be both given as well as considering that what I want to find out. Why I am mentioning in point 1 and point 2. Point 1 is consider, so they are the same way of looking the picture in two different angles. Point A is if d is given, then I know the distribution x which has got as per the concept of central limit theorem some expected value, where the expected value is here, which I am circling now. This is the sum of all the expected time for all the critical activities, and the variances, as you remember, it is basically the sum of all the time. So, this V T1 is for the first activity dot dot till the last one. So, considering there are n number of such jobs along the critical activities. So, if I find out the square root, it gives me the standard deviation of the whole set of activities of the critical path. Then I again use the probability of x minus e to the power t. This e to the power t is basically this the sum of all them, all of the sums of the critical paths corresponding to this square root. Under the square root you will have the sum of all the variances, that should be equal less than equal to d minus e t divided by again square root. So, I know E t, I know variance, I know d. So, this becomes a standard normal deviates realized value z 1. So, I check my standard table and find out the probability. So, this value alpha I find out, and I say to the team members who want an answer based on what percentage of the job would be finished within the due date, I say for example 70% of the work is finished. Well, I keep that as the set of information which I will be able to answer considering the point A which I mentioned where d was known. Now, consider the picture from the other point of view, which is point B. Consider d is not given and I am told that I have to finish about 75% of the job well in time, considering that there are some deadlines. Consider this deadline. I need to build up this whole complex which is a house, and consider the people want they want to move as fast as possible, considering the overall electrical system of the whole flat or the apartment is ready, the sewage system is ready, the water supply is ready, the security setup, the garage parking space, everything is ready. But due to some reason they are willing to move into the flat because it entails a huge amount of cost for the residents, that they are willing to move in even in spite of the fact that the overall boundary wall is still to be done. So, and I know that boundary wall is basically 10% of the job left. Boundary wall, then cementing of the overall area, or trying to basically have the roads outside the apartment building, that is not completed. So, consider that is 10% of the job left. So, now if I try to answer the question as per the concept which I mentioned, point B is that 90% of the job is finished, based on which I can tell the residents to come in. So, if 90% of the job is finished, I need to find out what is the deadline by which I need to find out. So, what I do is that I again take the same formula, probability of x less than equal to d, where d is now unknown to me, but what is known to me is that probability of x less than equal to d, that probability is 90%. So, what I do is that I again use the concept of central limit theorem, use the concept of standard normal deviate. I write the formula as it is, which is probability of inside the bracket, the formula is same, I am just going to repeat that, x minus E t, where E t is the total sum of the average time of the critical paths, divided by the square root of the variance of sum of all the variances of the critical paths. So, square root of that is standard deviation, less than equal to d, where d is now unknown, d minus E t, which is again E t value, I have repeated that time and again, divided by the sum square root of the sum of the variance. So, that probability is given as 90%. So, given 90% is that using very simplistic concept here, I understand we are using a very simplistic concept, but it will give you some idea that how the calculation can be done. I check the standard normal table. From there I find out that what is the realized value of z, small z, for which 90% is true. From there I find out z value, consider z value is given as, say for example, 2.5. This value I am just mentioning to you, it may not be 2.5. So, what I do is that I have this value of 2.5, this is equal to d minus e of t divided by the square root of the sum of the variance. So, 2.5 would now be multiplied by the square root of the sum of the variance, which is a known term, and I take e to the power t onto the left hand side, it becomes plus. So, only unknown in this whole equation which I am now going to highlight is d. So, d is basically 2.5 or whatever the value is multiplied by the square root of the sum of the variance plus the expected value of the sum of all the sums of the expected value of the critical path, I find out d. So, I can say to my project management team, to the set of engineers, see, if I need to finish off 90% of the work for this apartment, I need to finish it by this due date. So, based on that I recalculate how the work can be done. So, you are trying to see the picture from two different angles, but these two viewpoints gives you a lot of information that what is the state of the affairs for the job, whether d, which is the due date, is known or whether the due date is not known. Now, here I would like to mention 2 points. Point 1 is something related to the way of calculations we are doing. So, if you remember, in one of the last problems I did make a decision based on the fact that D1 and D2, which are the two deadlines, are known to me, and based on that I try to find out what is the percentage of the work which is to be finished between D1 and D2. Now, I could have also have taken the viewpoint from the other point of view, that I need to find out that what is the percentage of the work which would be finished for the same example which I just stated, that apartment building one, that 90% of the job is to be needed to be finished by that deadline. So, I find out d. So, consider that is d1, that value comes out to be known to me, and I write it down. Now, when I present it to my team, they say that no, let us also try to find out that rather than 90%, what is the due date based on which I can say that 92% of the work of the project is finished. Then I again redo the calculations, considering that now alpha is 0.92 and I find out a new deadline D2. So, these D1 and D2 are known to me, considering the fact that alpha in one case is 0.90 and another case 0.92, and then I place it to my team and I say like, look here, D1, D2 are known to me, so is it feasible. So, based on that I do a whole set of recalculation whether resource constraints are there, whether I need to basically use resources in some other activities and try to reduce the other activities to some extent, and then try to find out which is feasible. Now, whatever I have been talking about for the last 3 or 4 minutes may not make much sense to the people who may be, or the students, that saying that, well, you are trying to do the calculation in a very simplistic sense, does it serve the purpose? So, I will give you a very simple example. Say for example, we all know the famous laws of Newton, and in one of the formula it is force is equal to mass into acceleration. So, if somebody is from the commerce background, is from the science background, whoever is taking this course, I am sure you would have done the Newton's law of motion in class 10 or 12 or 11. So, in that case we do not consider any friction, but still the results which we get using force equal to mass into acceleration gives us very good results based on which we can do our calculations. Or say for example, in physics we have the time period simple harmonic motion of a simple pendulum, and we try to find out that what is the time period depending on what is the length of the string. Even though friction is not considered, gravitational force is not considered, any damping noise is not considered, and all these things, still we get very good results considering that the formula which is true in the theoretical sense. In the same way, the methodology we try to utilize or we have been discussing for the last 5-6 minutes based on the fact that we are trying to utilize the central limit theorem and we are trying to fit the normal distribution for this calculation, the overall answer gives us a very good picture how the work is going on, such that based on the fact we can go into the depth of trying to analyze the project in much detail. So, continuing in the 360th slide. So, therefore, if we wanted to determine the probability of that the project would finish no later than 32 weeks, we would need to determine the appropriate area under the normal curve up to the completion date on or before 32. So, if you remember, our average time was 30. Now, the actual probability we want to find out what percentage of the work would be finished is till that due date of 32. So, D is 32. So, we can use the standard normal equation to determine this probability, as I mentioned. And if you go into the concept, so what you have is that you find out the probability. So, the probability, the formula looks a little bit different, it is not, it is exactly the same. So, I need to find out the probability, and on the left hand side it was basically x minus E of t by variance of t, variance I am just writing V. So, that is equal to less than equal to d minus E of t divided by variance of t. So, look here what we have, you have the due date which is d here. So, just concentrate on the right hand side of the probability equation. So, I need to find out alpha. So, d is given as due date which is 32, which is here, I have written here. This expected value date of completion is given as per the problem which we just discussed was 30. So, 32 minus 30 comes in the numerator, which is d minus E of t, and in the denominator you have the square root of the variance, which I just discussed in the last two slides. If you see the problem, it was 2.78. So, it will be divided by 278. So, the value comes out to be 72%, which means that within that due date of 32 number of weeks, considering the average value is 30 for completing that whole project, considering is the critical path, we would be able to finish about 72% of the job. And then again, taking the viewpoint of B, which I did mention, you can also find out that what is the due date considering 80% of the job is finished, or what is the overall probability of the work would be finished between the due dates of, say for example 32 to 33, and all these calculations can be done. So, now we will come to the concept of crashing the jobs. Crashing the jobs, first I will give you a feel in the qualitative sense and then go into trying to basically solve a problem. So, under some circumstances it may be necessary to find ways to accelerate the completion of a project. There are a number of reasons why we need to speed up the project, and including some of the reasons are, if you see the bullet points, the initial schedule was too optimistic. We basically planned in such a way, we thought everything would be on time. The resources would be utilized just optimally, resources would be arriving at the optimal time, manpower would be available, or the resources based on which we will try to use the raw materials would be arriving on time. So, these were some optimistic thought process. So, in order to complete the project on time, we were forced to find ways to speed up the project. So, now market needs have changed. Consider suddenly we find out that the prices of one of the raw materials is going to increase by drastically within 2 weeks, which means that I have to basically plan my work accordingly, or the customer demands that the project should be delivered not on the 30th week, but say for example it has to be delivered on the 20th week. So, there can be different consequences of that, or say for example we suddenly face a technology constraint, like you are digging the tunnel in Switzerland and suddenly you face a huge amount of technology barrier, where you need to do a special type of excavating under the Alps, and their technology need is of huge quantum. So, those changes which you are not aware, they come into the picture. So, perhaps you learn that a competitor, so another case can be competitor who is working on a similar projects suddenly comes with a technology breakthrough, and he or she, the person who is doing the other project, is progressing very fast on those lines. So, it is there what I am reading. Perhaps we learn that a competitor is working on a similar product and intends to introduce its earlier than the original due date, based on which you were planning, because you wanted to flood the market with a similar type of product with respect to the competitor coming a little bit ahead of time, but suddenly the overall game has changed. So, there you have to basically take a very rational and realistic thought process. Another can be because profit and the market share comes to the first company. So, if in case it is coming, you have to take the decisions accordingly. So, to get the project to the market, it makes sense to accelerate the project in time, and considering all these things, you have to re-evaluate the process. So, I will go in the 30th slide trying to crash a job and then try to give a viewpoint that how it can be done in a very simplistic sense for a simple problem at hand. Thank you very much.